Where are you calling in from, Mario?
I'm in the office in Chicago.
Chicago. Okay, nice.
Where are you at?
I'm in Washington, D.C. here
Oh,
in a new co-working space for my new project.
okay.
The last time we spoke, I was working on finishing up the Smithsonian Castle, so now I'm moved on to a different one here.
Great. Smithsonian Castle. That's beautiful.
Yeah, it was gorgeous, fun one to be on, no doubt. I was very privileged to be on it, be a
Mhm.
part of it. Hey Ty, how are you?
Hey Mike, how's it going? I'm doing well.
Good, good.
Yeah, so you had a chance to chat with Mario a little.
Yeah, catching up a little bit here.
Yeah,
Mhm.
I'm digging the mustache.
yeah, I switch back and forth between mustache and full beard,
Yeah.
depending on the how hot it is outside mostly.
Yeah,
I tried one out last week and promptly shaved it off about 2 seconds after trying it on for size.
hmm
mhm. I'm growing masters since I was, I guess, 14, 15 years old
Oh yeah?
Yeah.
in place. But I have a little stitch here because I had a bicycle accident, so it's hiding.
I have
Uh,
one too. I've right
that's
here from a hockey incident.
all right. Yeah.
So maybe I do need to do mustache.
Yeah.
And I've just got one because I can look just like Ned Flanders.
There you go.
Yeah.
All right. We all have a reason for master.
I assumed Ty was trying to copy you, Mario. That's what I thought.
Yeah. Uh, okay.
We had about 70 people sign up today,
Oh, that's
Great.
so it's
good count.
fantastic.
Yeah. Yeah.
Yeah. And you got the sign up sheet from me for just recording everyone's participation.
Yep. Yeah, I'll either fill that out or do some
Mm.
sort of like Excel spreadsheet with their AI numbers.
Yeah. Yeah, but basically, if I can just get their AI numbers, that's the easiest way to do a
Yeah.
bulk upload. There is a way to do name searches, but it's really weird because it's not actually following someone's exact name. It's however they registered. So if somebody registered as John Smith versus Jonathan Smith versus Jonathan A. Smith, they all come up as different things, and
Hmm.
it does not search. If you don't have it typed exactly, it won't show up. So we get about occasionally get people who just give names, and it's a pain in the butt
It's
to
such a
sort
pain.
them. Yeah.
I have to admit, for my first one or two, I was trying to do it by names.
Yeah.
It would I had to look at where they're registered as opposed to where I know they're based out of. And you get a
Yeah.
few at a time. For John Smith, you get 25 uploads. It's like, it was,
And you also get the weird ones of people who have moved but haven't updated their location and they'll still
Mhm.
be registered in places that they aren't really or
Yeah.
don't make sense.
yep.
Yeah.
No, thankfully we require, if they're going to
Yeah.
ask for the
Give
credits, we
give
require
us the
it.
number. That is so easy for us to
So
do.
much easier. So much
Yeah.
easier. How's my audio? Sometimes I'm experiencing there's a constant buzzing in the background.
I'm not hearing anything on that.
Yeah, sounds pretty good.
Great, thank you. We'll give it a couple extra minutes if that's okay with you too.
Sure.
Sure. Sure, sure.
Let the stragglers join in.
See, someone was asking if they're not AIA but need credits for a license, they can get a certificate. We can make those. We have to manually make them. I don't mind doing a couple of them. I don't want to do 70 of them.
No, don't worry
So,
about it. I
yeah.
I manually make those, so
Okay. So if you've got
um,
those, that'll be
the
fine.
person that asked, yes, if you signed up for that when you registered, yes, we'll get you a
Okay.
certificate. Jeez.
Yeah. And then for questions, we usually let folks do questions at the end of each of the four segments. Since there's so many people, I would say just have people type their questions into the chat and I'll just go through and answer them at the end of each segment.
Perfect.
The first two segments are the bulk majority of the presentation. The second two are a little more on just sort of logistics and spec writing, formatting, but the first two are the ones that really go over the interesting stuff. So
Hmm.
that's usually where we get a bit more of the Q&A in there.
Sounds like a similar format to the blaster.
It's the identical format to the plaster. The only one that we have that's really a different format is the concrete one, because with AIA, you're supposed to do the four specific learning objectives. But with the concrete one, we took the four learning objectives, basically cut them all up and blended them into three separate topics just for how it better matches the methods of concrete restoration.
Okay.
But most of them are still following that same format, so I wouldn't worry too much.
Maybe I'll survey the group, see if we're interested in having the concrete one as well. Sure,
The
sure.
concrete one's pretty interesting. It's one of our newer ones, and
Yeah.
it basically covers the topic of how to repair existing concrete, how to do surface repair, how to do patching repair, and how to do full unit replacement repair. With trying to actually do your own replication of units. So it gets into stuff of like mold making, surface finishing with the weathering,
Hmm.
um, some stuff on surface deterioration, because that's a big thing that we see, not specifically exclusive to historic concrete, but new concrete, especially architectural concrete, that molds come off and it just looks terrible. So there are ways to do sort of refinishing and resurfacing of concrete. I mean, one of
Without
the
damaging it
biggest,
at all? No damages?
No,
it,
it's we call it aesthetic improvement.
Mm.
How it is sort of a projects, Todo Ando projects that were completed in the United States, and we established various techniques that are very successful.
yeah, so mostly, yeah, aesthetic improvements. So the concrete was poured correctly, but it's supposed to be like a raw finished surface. So going back and doing minor surface texture and color repairs to basically blend it correctly. Um, a lot of the historic concrete repair that we see is somebody put a bunch of boreholes in a wall to hang an awning and they took it off. And now, how do you make it look like there wasn't an awning on
Sure.
there?
Yeah.
Sure, sure.
There are definitely more extensive ones. We've got a good case study of a hotel down in San Antonio that was basically all decorative concrete. And then it was an open air atrium on top of the hotel. Then they enclosed it and put a roof on it and had decades of basically rubberized roofing membranes painted on top of it. And then they wanted to open it back up. So tearing all of that out and basically getting the concrete with multiple different conditions, exterior exposure, exterior covered by bonding agents, interior exposure with different types of paints, and just trying to establish how to do the blending of the different repair and restorations so that they all sort of come together.
That sounds incredible.
Yeah.
Incredibly difficult as well.
Yeah. So yeah, if you want to circle back in a couple of months, happy to do another one with that.
I think we have to now after hearing that.
Yeah. Yeah. And I mean, DC has plenty of architectural concrete, so I think
Yeah.
it's a place that you could definitely get a lot of benefit out of this. The mortar repair is our original presentation, though. So it is sort of the long-term basis of everything we really did with starting the company 28 years ago, 27, 28 years ago, somewhere in there.
Let's go ahead and get started here.
Yeah, that sounds good.
Okay.
Thank you everyone for joining. You may or may not recognize the two gentlemen on with us, Mario and Ty. They did a wonderful repairing historic lime plaster presentation for us a few months back. It was incredibly well received. I've never gotten so many emails asking for the recordings and the slide decks in my life. So I had to come back to them and see what else we could bother them for. And we have this wonderful Repointing Historic Masonry webinar today. Quickly, if you weren't on the first one, Mario is the president and owner of Mario. Do I say it wrong? Is it Marion or Marion Restoration?
It's Marian Restoration.
Marion Restoration. Thank you. Which is one of the region's top masonry restoration firms, and U.S. Heritage Group, which is a company dedicated to making traditional materials and training available to architects, contractors, government agencies, preservationists, and owners of institutional, commercial, and residential properties. Mario's got over 35 years of experience on masonry buildings and restoration and extensive training. He is often considered the country's foremost masonry expert. Mario, thanks for being here. And we're also joined by Ty, the Director of Operations at U.S. Heritage Group. Ty's experience includes 12 years of providing consulting, training, and material supply to hundreds of masonry restoration / preservation projects on heritage sites across North America. Ty actively participates as a member of professional organizations, including the National Trust for Historic Preservation, APT International here, ASTM International, and the American Institute of Architects as a continuing education provider for over 8 years now. So Ty, Mario, thank you so much for being here. I will give you the floor.
Thank you.
Okay. Thank you, Matt. So thank you all for joining us today. Today's presentation is going to cover historic mortar restoration, mainly with a focus on traditional lime mortars, but we will touch on some of the other types of traditional mortars you would see in some of the older type of heritage projects. I'll go ahead and start sharing.
Hey, really quick, Ty, sorry.
Yes.
Just the format of this, it's broken up into 4 segments. If you have questions throughout the presentation, just put them in the chat. And I think Ty, you're going to take a short breath between each segments and read any questions that we may have out there,
Yep.
maybe towards the end.
Sounds good.
Up to you.
Okay, so once again, thank you all for joining me. So just going over some quick housekeeping on our CES. Here's our title slide explaining the presentation, course number, our provider number, the standard AIA CES compliance template, and then our copyright template. We're happy to share the slide deck at the end of the presentation. We just request you don't distribute it outside of your organizations, but if you want it for reference, we're happy for you to have that as a resource. So this course of historic repointing masonry guides specifiers through a system of best practices from planning to installation that consistently produces excellent results for projects that involve repointing of historic structures. We like to I've got something weird going on here. Just a minute. There we go. We like to start all of our presentations with this quotation from Aldous Kluss. He is a notable architect in the early days of the AIA, but he said, "The observations and conclusions of leading experts conflict sometimes, and neither contestant may be in a position to adduce strict proofs. I have therefore endeavored to condense from the scattered information such largely accepted facts and theories as to tend to the direct attention of the busy architect to the vital points at issue." We really take this quotation to mean that there are a lot of opinions, a lot of methods, a lot of options for historic building restoration. It's not necessarily that there's one correct answer, there can be more than one, but the understanding and the knowledge of what is available as a material, as a practice, as a resource is essential and constantly evolving. And we really try and bring all of these modern concepts together in one source so that you can find the best way to fix your projects and to successfully execute your restorations. We have a couple of resources that we always touch on, starting in order from the Building Limes Forum, the Association for Preservation Technologies, the National Park Service and their preservation brief documents, and the ASTM International. We list these resources in this order because starting from the top to the bottom, they are most focused on specifically lime mortars and lime masonry restoration, and then becoming broader and broader in terms of their scope of coverage as they move down into general preservation, into National Park Service preservation briefs, which cover items outside of the scope of what the APT would do. And then the ASTM International that covers building standards in general, not just restoration. We also like to do a quick run through of some best practices that we will be touching and digging deeper into later in the presentation. When you are working on a historic masonry project, the first thing you want to do is identify the root cause of your masonry deterioration or the damage. You want to analyze and match any materials on the site to make sure you have the proper replacement materials. You want to be able to accurately identify the scope of the project, establish benchmarks for the repair work to be done with a masonry specialist, whether that is the final mason or someone else. Develop very tight and controlled specifications based on those approved execution mock-ups and materials that require very good quality control on whatever is going into the building. A good practice is to pre-qualify your bidders based on the established benchmark mock-ups. So if a bidder wants to actually work on the project, they need to be able to achieve an equivalent level of repair as something that's already been established and approved. You can also require pre-mobilization training or certifications and verifications of the skills of the masons, typically on site where they will be doing the actual work to make sure they have the right capabilities there. You need to confirm your mortar sources and training submittals via the bid documents. And then a very important one, you have to continually do your on-site quality audits to make sure that the established levels of quality control are being maintained throughout the project. We break this presentation down into 4 general areas of learning objectives. The first is a review of common problems related to masonry structures and identifying the source of those issues. Second, we're going to go over suitable and unsuitable materials and techniques for historic mortar restoration. Third, we're going to go over some of the details on specification writing with regards specifically to historic masonry projects. And finally, we're going to go over some of those on-site audit and execution items that you will want to bear in mind as you are going through the actual kind of construction process of your project. So starting with objective number 1, identify common masonry problems related to repointing when visually assessing a historic masonry structure. Some of the primary causes of damage in these types of historic buildings is mechanics. The mechanics of the building, how it is functioning structurally, chemically, and it's really broken down into a couple of categories. the most common one being issues with water movement, then issues with freeze-thaw cycling, biological growth, and building movement. When we talk about water movement, you need to understand the idea of capillary action. So the smaller a crack or an opening, the more suction it will actually have of pulling water into a wall. So in a strange way, smaller cracks can actually cause more water issues than larger cracks because they will be more prone to higher levels of absorption. When we are looking at water movement as well as freeze thaw and salt migration, in a traditional masonry wall with a permeable mortar where the wall mortar is going to be more permeable than the masonry units themselves, water will be absorbed into the wall through three general sources. One is through the exterior surface through rain exposure. The second is through rising damp through the foundation, pulling up from the bottom of the wall. And the third is from general occupation related moisture. So just human occupation, respiration, perspiration, and that would be coming from the inside of the building. In a traditional masonry structure, the water will absorb into the wall, and then we'll look for the easiest and most permeable channel to exit the wall, which is traditionally going to be the mortar itself. The mortar will have the water evaporate through it. It will carry salts. It will carry whatever kind of deterioration is going on. And then the mortar is functioning as the sacrificial portion of the wall because it's the easiest part to repair. The issue comes when you start to repair buildings with incompatible mortars and materials, so mortars that are harder or less permeable than the originals. You're still going to be absorbing water from all three of those locations, but now when the water is escaping, it's going to follow the path of least resistance. And if you have something like a high cement mortar in that mortar joint, it's going to act as a plug and force that water to move around the mortar joint and start exiting through the face of the masonry units. So now the deterioration from the salt, from the freeze thaw, you're going to have spalling deterioration in the face of your bricks or stones instead of in the mortar, and they are much more difficult to repair. You also run into issues with thermal expansion and contraction incompatibility with modern mortars. So historic mortars, lime mortars, are relatively flexible. They have a degree of movement. So when there's expansion and contraction, they're able to stretch and compress with the masonry units around them. Modern cement mortars are fairly inflexible. They don't have the same kind of movement. They're much more rigid. So in cases of wall expansion and contraction, they can actually chip or spall or create separations in the mortar joints of the bricks because they lack that movement. If you look at a lot of old buildings, there weren't really expansion joints in them because the mortars were flexible enough to spread that expansion across the entire face instead of having to have specific seams every so many feet. You can run into issues with biological growth, especially in walls where there is moisture issues, because the biologicals will basically seek out a source of water. And if that water is getting trapped within the wall, a plant in this case can grow roots, can seep in, and as those roots grow, it will open the wall crack up larger and larger. You're also going to see different problems with the conditions of the buildings, usually related to the original design or installation of the wall itself, ongoing operation and maintenance issues, or entire failures of the building envelope. When you're looking for design and installation issues, it's typically going to be something along the lines of improperly installed roofs or cappings or copings, as well as sills, basically areas where there should be water protection that is failing and is allowing liquid water to soak into the surface of the wall. You're also potentially going to run into issues with damp courses and flashing, where there is too much water coming up from the outside base of the wall. And you can see additional issues with site drainage and grading, usually if there are changes to the surroundings of the building. So new sidewalks put in, changes to the water table based on construction conditions, not even next to the building, but nearby it, that can change how water is flowing around the building and from that into the building. You also are going to see a lot of issues based on improper maintenance, repairs, or ongoing operations. So bad previous repoint campaigns with improper materials or techniques, the application of waterproofing agents or paints onto historic masonry. And then a big one is the use of or excessive use of de-icing salts that will be adding a lot more salts and self-fluorescence into the wall, which will then become efflorescence and damage. With improper material selection, a big one is essentially putting mortars that are too hard or too rigid into the wall. This is an example of a limestone mortar joint that was a traditional lime mortar joint replaced with a cement lime mix. You can tell it's a cement mix because of the very smooth tooled face of the joint. A lime mortar would be a much more open, sort of sandy texture. But you can see in this case, this mortar joint was installed and it was so rigid that it actually created its own expansion joints, those cracks running perpendicular at almost even intervals going down the length of the mortar joint. In addition to that, because of the hard rigidity and impermeability of the mortar joint, you're starting to see deterioration at the edges of the limestone. In a more extreme case, you can see de-icing salts inappropriately used on, in this case, paver stones. The mortar joints of these stones were not originally there. They were installed at a later date. And while the salts previously were allowed to drain off, they're now getting cooled and absorbed into the stone and basically just disintegrating the top coat of it. But the mortar is perfectly intact. So it's doing what they thought it was going to do, even if that wasn't the right decision to start with. Waterproofing is something that is a very large issue for historic projects. Modern waterproofing is really meant to account for all those micro cracks that appear in modern cement mortars, concretes, things like that, as a way to fill them in. But when you put waterproofing agents on historic materials, you're actually inhibiting the flow of moisture that should be happening within those walls, and you're trapping that moisture just below the surface of the walls, and that will cause the deterioration of the surfaces. The same thing will happen with paints. You're trapping moisture just on the surface or just below the surface, and without any ability for it to escape, it's going to accumulate. It will bring salts to the surface. It will cause water to just sort of saturate in there and slowly break down the surface of your mortar and masonry units. You're also going to see issues with the flow of water across the building. So in this case, splashback, issues with new concrete sidewalks, new damp courses that were installed that are taking water that would normally be able to escape lower on the wall or even be moved away from the wall through drainage and forcing it to rise higher and higher as you try and deal with the problem lower in the wall. You also deal with issues with leaks in walls, so gutters, roof systems that are leaking, improper sills or flashing around windows, places where liquid water is just flowing into the wall itself and not able to either be diverted or escape with off the surface of the wall. Efflorescing is always a major concern on historic projects because the salts are so destructive, especially to softer masonry units. You're going to be dealing with efflorescence from sources like de-icing salts, but you also potentially are going to be dealing with efflorescence from cements that contain sulfates from their manufacturing process that are now being forced out the wall, either from recent repairs or from changes in the permeability of the walls. Soiling is another condition, especially in more urban areas, where things like automotive pollution or smog can bond to the surface of traditional stone or mortars and have a catalytic chemical reaction that will convert these limestone into crustacean or different types of gypsum that will deteriorate the surface of the stone over time. You can also run into issues with actual wall or foundation mechanical issues, so cracks in the walls, separation of mortars that will allow liquid water into the wall. The effects you're going to see from all these conditions is cases of water saturation, mortar failure, masonry unit failure, and structural failure. For water saturation failure, the most visible one you can see is interior efflorescence. It's very common to see efflorescence on the outside because that's the transmission path of the masonry, of the water through the masonry. If your saturation issues become so much of an issue, the water is going to force its way through the inside of the building, and that's where you will see that deterioration on the interior face. You can see failure in your mortar through cracking, in this case, stairway cracking. You can see mortar failure of weathering away of the mortar. We include this one because it technically is a failure, but this is the most preferred form of mortar failure because this is the mortar doing what it's supposed to do. The mortar is deteriorating back while still maintaining the integrity of the wall. And in this case, you can go back and just clean off the surface of the recessed mortar joints and repoint them to whatever your desired profile is. Mortar failure in a bad way is decomposition, where you have something going on inside the wall, typically a saturation of moisture or an encapsulation of a thin layer of a harder cement lime mortar that will cause the bedding mortar to basically deteriorate into sand. This is just another example of it, even on stronger stones. The same type of application of improper mortar just over the surface can cause significant damage to the original mortar behind it. You can run into extreme cases of masonry unit failure with the use of mortars that are too strong. In this case, these are very high cement mortars that were applied to this wall. The mortar is stronger than the brick. So when there is movement in the building, instead of that movement being transferred through the mortar is holding the brick in place and actually cracking the mortar along with the brick as those cracks move through the wall instead of targeting them just to the mortar, which would be the ideal way to relieve that pressure. Spalling happens when the moisture is not allowed to escape through the surface of the bricks and basically breaks the surface. This is a case of a waterproofing agent that was applied and essentially permeated about a 1/4 inch into the surface of the brick and then stopped. So all the water movement just stopped exactly at that thickness of the brick, and it started depositing salts and basically sheared the face of the brick off. Spalling can even occur in extremely hard mortars, stones. This is actually granite stone that was pointed up with a high strength cement mortar. And the mortar was so strong, it's not specifically the hardness of the mortar, but the impermeability that's causing water to deteriorate these edges of this granite stone. You also get the same effect from paints applied to large permeable stones, such as sandstone in this case. Basically, all the areas that were painted are just shearing off in order to just release the pressure of the moisture that is behind these painted areas. You're also going to see just a full decomposition of a masonry unit. If a brick is kept saturated for too long, eventually the entire crystalline structure of the brick is going to just fall apart. And the brick itself may still be there, but it's just completely lost all coherency, and those need to be replaced. And then finally, we're looking at structural failures. In this case, the full deterioration and washout of the mortar and the foundation wall basically made all the masonry units, they're still intact, but they're just settling on each other, and it's causing a sagging of the wall above this foundation area. We're going to do a quick case study and then I'll check the questions. This is the Mark Abbott Lighthouse. It was the first lighthouse in Santa Cruz, California, originally built in 1869. It was built along the coastline, and the area it was built started to erode. So for the safety of the building, they dismantled the lighthouse in 1948 and kept all of the components of it. So the lantern, the windows, and the bricks and the masonry units, they kept them in storage until they raised money to rebuild the lighthouse in a new stable piece of land in 1967. So almost 100 years after the lighthouse was originally built, it was rebuilt, but it was rebuilt using modern cement mortars instead of the traditional lime mortars it was originally constructed with. And what we saw was within just a matter of years, the bricks started to fall apart and decay because the mortar was so strong and the conditions of a lighthouse on the coast are so extreme that the bricks just had no chance of surviving. Looking close at the wall itself, you see that the mortar in all of these joints is perfectly intact. Even in the areas where the bricks are more or less disappearing, the mortar is still fully there, fully laid up, but the bricks are falling apart piece by piece. And we've actually gone back to this lighthouse a couple of times over the decades, and we see more and more deterioration, more and more bricks that are so destroyed that they're being replaced. And the ironic thing of it is when they replace the damaged bricks, all of the moisture that was escaping through those damaged bricks is now being forced into bricks that are not or were not damaged, that were original, and causing them to be damaged. So every time they replace a section of bricks without actually removing and replacing the mortar, which at this point can't really be done, they're causing more and more damage to the original fabric of the building by repairing the damage that is existing on the fabric. So I'll take a moment to check the chat. So siloxane-based liquid damp course. So there are certain liquid damp courses that can have an appropriate effect on rising damp. The best option initially, though, is to address the source of the rising damp. Sometimes you'll get rising damp due to drainage issues or due to changes in the operation of the building. So why is there rising damp now? Is there a new sidewalk that's been installed that's pushing water against the wall higher or preventing it from draining out? Is there areas that were painted or coated that are now forcing water out of a different side? We've had successes and we've also had failures with different chemical injection damp course materials. The specific material selection is very dependent on the project. They can work well. There are other damp course materials that can work in other conditions. So it's not something I would fully write off, but it's something that is very project specific. So I would not recommend just jumping into a one size fits all solution for that. The next question is, any advice for immediate efflorescence after mortar repairs in historic stone walls with lime mortar or causes? If you're seeing immediate efflorescence after a historic repair with a lime mortar, then you're likely seeing efflorescence from a source outside of the repair itself. Something that is occasionally seen is if this is a repair of a previous repair, there could be sulfates that were accumulated from improper use of concrete-based masonry units or concrete-based mortars in the past that was trapped in the wall. And now that there's permeability to allow the moisture to escape at a faster rate, it is drawing those salts out to the surface. You can also see efflorescence if you are using cement-based mortars, even if they are historic cement mortars like type O's or type K's, if there is an excessive amount of cement within or sulfates within the cement itself. We'll touch on that in the next section. But the way that you would address that for immediate efflorescence repair, assuming that it is a source of efflorescence that is a temporary source and not sort of a permanent source of efflorescence, like continuous rising damp of contaminated groundwater or continuous improper use of de-icing salts. You can use salt neutralization, or our preferred method is actually salt extraction with the use of distilled water and poultice, where you're going to draw these salts out of the wall into some sort of carrier medium or a poultice, and basically just pull the salts out of the wall in order to remove any excess salts. And then once they're gone, they should not be coming back unless there's an alternate source of the salts that you would have to address. One more question. How does tooling a mortar joint affect water evaporation? Can a joint be tooled? Can a joint be overworked or packed too hard? Yes, it can, absolutely. We'll be touching on proper joint tooling techniques in the next section. But essentially, you have a chemical permeability based on the formulation of the mortars that you're putting in, but you also have mechanical permeability. It is possible to take a pure lime mortar and tool and work the joint so much that it is essentially waterproof just by mechanically tightening the physical structure of the joint enough. So when you're doing historic work, you need to finish and tool your joints in a certain way that we will cover that should leave them open and permeable. Uh, in certain cases, outside of the scope of this presentation, there may be cases where you want to tighten or tool the joints a certain way to add in some water restrictions, but it's not meant to be intentional. You don't want it to be an accidental over tooling of the joint because that will cause repair issues down the road. So our next section that we're going to go over is materials and methods. Basically, we're going to talk about what are the appropriate and inappropriate materials and techniques for repointing historic structures. We'll start with an overview of materials, which are going to be aggregates, binders, pigments, and water. Those are the three or four materials that should be included in a historic mortar. There should be no other materials in there. Starting with a review of aggregates, you want your sands and your mortars to be clean, dry, and well graded. You want to avoid anything with too much dust or any organic material, sorry. And it's important to avoid damp sand and unknown gradation sand because they can cause issues with your mixes. When we talk about dry sand, we're talking about kiln dried or bone dry sand, something that's typically 1 to 2% moisture, sometimes even drier. Standard pit sand that you get bulk delivered is usually in the 4 to 6% moisture range, possibly higher. But what will happen is if you take a purely dry sand, which has a consistent density, and you add a small amount of water to it, so in this case, about these are half liter, but say these are 3 liters of mason sand, you add a half a liter of water to it, it's going to cause the sand to bulk to larger than the original volume. And basically 3 liters of sand becomes 4.5 liters of sand by adding 1/2 of a liter of water to it. So if you're dealing with damp sands, the level of moisture in that can wildly change the actual volume of sand. And in most cases, you're doing your formulations based on dry volume, not damp volume. So you can get very unbalanced mortar mixes if you use damp sand without having any kind of measurements in place to account for the moisture. Specifically for the aggregate, you want to use aggregate where your largest particles are about 1/3 of a joint width of the mortar joint you're using. The goal of that is you want larger particles to avoid shrinkage cracking, but you want the particles to be small enough that there are not going to be 2 particles that basically lock together within the mortar joint and create a barrier for the proper compaction of the mortar. You also want particles that are round to subangular in shape. Very sharp sands will do the same thing as larger particles where they'll get caught against each other and won't be able to properly move or compact in a mortar mix into the mortar joint. When we talk about gradation or distribution, you need to make sure that your sand is following a bell curve shaped distribution with the majority of it in some sort of medium central location with a tail end in larger sands and a tail end in smaller sands. This type of mix will reduce the void space in the sand mix that needs to be filled by the binder, the lime and cement, and reduce the possibility of air pockets or void spaces forming in your mortar mix. The second sand here is an improper sand gradation. It actually is more likely 2 sands, a fine sand and a coarse sand that were mixed together. But this sand mix is going to result in a much higher amount of void space that will either need to be filled with an excessive amount of lime and cement or will leave air pockets that will cause all kinds of issues with freeze thaw or water accumulation within the wall. For binders, there are a number of binders that are typically used in historic mortars. The most classically traditional one is going to be lime putty mortars, slaked from high calcium quicklime. You age it a minimum of 3 months in order to allow the lime to work itself into a good plasticky consistency. This is what we use for the majority of our traditional lime mortars. There are cases where the mortar would have originally been mixed with a hot mix or a quicklime mix. Due to ease of installation and safety concerns, lime putty is what they use in those cases. You're also going to see instances of historic projects utilizing natural hydraulic limes, which are limes that have naturally occurring pozzolans within them, which make them react hydraulically and set up similar to a cement without having a cement, as well as the use of natural cements, like you would see often in the New England area, like Rosendale Natural Cements. But there were natural cement factories all across the US, mostly in the mid to late 1800s. You're also going to run into a lot of projects, especially after the 1900s, that have small amounts of cement in them. White Portland cement is our recommended material for cement mixes due to consistencies in color and the reduction of sulfates within it. But you will run into projects that contain gray Portland cement as well. Gray Portland cement does not have the consistency of color and is more prone to efflorescing due to a potential higher sulfate content. And then also hydrated lime is used in mixes only if originally present, and it needs to be mixed with a cement in order to set up correctly. You never want to use a type S hydrated lime on its own. It will not bond in the correct format the way that a lime putty or a traditional lime mortar. You don't want to soak lime putty from hydrated lime. You don't want to use lime putty that is dolomitic or high magnesium, as it won't be setting up correctly on its own either. And you don't want to use masonry cements because there's no actual lime in masonry cement. Masonry cement is just a mixture of Portland cement and ground limestone dust. There's something in lime manufacturing called the lime cycle, which is basically a closed loop circle of how lime is manufactured. You start with limestone, which is calcium carbonate. You fire it in a kiln and it burns off one carbon dioxide molecule and becomes calcium oxide or quicklime. At that point, you can either drown the quicklime in a excess of water to create lime putty, which is a calcium hydroxide, or you can add a limited amount of water to it to convert it to calcium hydroxide, but not enough to convert it to a putty. In that case, it would convert to a powder, and that is your hydrated lime that is most commonly used. There's a couple of additional ingredients that are used in mortars, specifically pigments. You need to follow pigments that are in compliance with ASTM C979, which is mineral oxide pigments for use in masonry. You don't want to use organic pigments. They won't maintain their color. They'll break down over time and potentially will compromise the strength of the mix. You don't really want to use any other admixes besides pigments. So nothing like accelerants, antifreeze, bonding agents. They're going to actually cause negative effects in most restoration mortars. And it doesn't come up too much, but occasionally you run into issues with your water supply for your job. You need potable water in order to have a proper mortar mix. Extreme cases of this are, we've done a number of projects on lighthouses on islands that don't have running water. And so the option is to bring in water on its own or use lime putty mortars that are already pre-mixed with water because there's no available water to use on the islands. We're going to do a quick overview of the methods, the proper methods to repair these mortars, starting with removal. You need to make sure that you're using the right kind of tools for removal. The entire focus of this is to not damage the existing masonry units. The masonry units need to be protected at all costs during removal. So using grinders with diamond wheels much narrower than the mortar joints, hand mortar removal saws, stone carving hammers, or just hammer and chisels, grout removing tools. You don't want to use anything that's going to have an uncontrolled removal mechanics. So grinders with multiple wheels or with wide wheels that could notch the bricks, or uncontrolled reciprocating or chisels that would potentially notch into the brick uncontrolled. These are the typical kind of tools you would see for this type of removal. The best method for removal is called the center cut method, where you're essentially going to grind out a thin line in the center of the mortar, and then you're going to take a hammer and chisel and just tap out the top and the bottom now that there's space for you to actually crack the mortar from the top and the bottom of the mortar joint. After the bed joints are cleared out, you can go back and you tap out the head joints up and down with a hand chisel. You do not want to use a grinding wheel for the head joints. So this is sort of visually what you're going to do. You go through and you grind out just a center channel and then go and crack the top and bottom of each mortar joint with a hammer and chisel. It's a fairly straightforward process once you can open it up. This is a more extreme example of somebody using a wide grinder in order to try and just get through as fast as they can, as well as grinding on head joints. It really is not possible to grind head joints. You're always going to notch the bricks above and below. But yeah, don't do this. When you're using your measurement tools, you need to be very careful when you are measuring either by weight or by volume. All mortar formulations are basically called out for by volume, but are actually mixed by weight. So a 1-to-3 mixture of a binder mix to sand mix is specifically calling out 1 part volume of binder to 3 parts volume of sand. But you really need to do that measurement by the bulk density of these materials. This is an example of pigment issues you can see by weight versus volume. These are 2 samples of pigment we took from the same pigment bag, and we just vibrated one to settle it down, and the other one we left fluffy of its bulk density coming out of the bag. And there's about probably a quarter, 25% volume difference in this, which for pigments would cause a wildly different color effect when you're actually measuring. For your mixing, you need to make sure you're using the right kind of mixer. Mortars for historic repointing are a fairly dry and stiff mix, something like a stiff brown sugar or snowball consistency, versus more modern mixes that can be mixed into a wetter concrete consistency. So because of that, you need something with paddle arms to really mix and knead the mortar into the finished mix. A tumbler mix will either not fully mix the mortar because it's going to be too dry, or it will over mix the mortar into too wet of a consistency, like something that is actually flowable. For your installation tools, once again, the main goal of this is to not damage the existing masonry units. So you're going to be using manual pump water sprayers, hand tools like hawks, trowels, pointers that are the right size for the mortar joint. And then if you're getting into any unique finishing profiles or joint profiles, the proper types of jointers, bead jointers, ribbon jointers. And finally, as we talked about in the question of the proper tooling of the joints, a churn brush or some kind of brush to open up the mortar joint is going to be the final step to avoid over tooling or over slicking of the mix. Generally, grout guns and grout bags don't work for historic mortars because you have to make them too flowable for the proper curing of a mortar joint with a historic mortar. So when you're doing your installation, depending on the mortar type, you need to have the proper surface saturation of water, and the proper depth of a mortar joint pointing lift. You want your surface to be what's called surface saturated dry, where the surface is damp to the touch but doesn't have any liquid water standing on it. This can require 3-4 applications of just taking a hose and soaking down the wall and just letting it sit for 10-15 minutes. Old historic walls with older bricks and stone are just sponges. They will soak up so much water you would not believe it. And a lot of masons that don't have experience with historic mortars will spray down a wall with a misting bottle, say it's good, put their mortar in. This brick and stone will suck all of the water out of the mortar immediately, and it will basically just turn to chalk in the wall and fall out. So making sure that you have enough water in there, that you're not going to have too much suction out of your mortar joints is essential. In addition to that, you need to make sure that you're installing your mortar at an appropriate thickness. Because of the nature of these mortars, pure lime mortars like hydraulic limes and lime putties can be installed as thick as is practical. You're basically just dealing with the slump of the mortar mix. So in practice, 2 to 3 inches is achievable of a single depth of lift with these kind of mortars. Potentially more if the conditions are right, but you're probably not going to be pointing that deep in most cases. For lime cement mixes, the best practice, which has limited practical application, is to install 1/4 inch at a time. 1/4 inch will allow any shrinkage to occur within the wall without cracking or opening up because of the thickness, causing a greater movement length of cracking. So it's difficult to get masons to do 1/4 inch at a time, but it is a best practice that will minimize the possibility of shrinkage cracking forming. When you're doing your actual mortar joints, you're going to be hand packing it into the joint with a pointer tool. Pointer tool needs to be the correct width to actually fit inside the mortar joint and properly impact it. And then once you've got your mortar all the way filled in, you're going to overfill the mortar joint just a little bit, about 1/8 of an inch, possibly even less. But you want enough that every surface of that mortar joint is going to be overfilled enough for basically cutting back. At that point, you need to wait for the mortar to reach an appropriate stiffness or hardness, which we like to call thumbprint hard. Basically, the point at which the mortar is firmed up enough that you can stick the pad of your thumb onto the mortar joint and press in, and it won't move, but you can still dig your thumbnail or fingernail into it to scratch it away a little. At that point, you can go back and using a trowel or some sort of pointing tool, cut back the mortar joint to whatever the appropriate profile that has been predetermined is. So whether that's a flush joint, a recessed joint, or a more decorative joint like a bead joint or something else, you need to wait for it to reach this point before you do that. Finally, you're going to strike with a churn brush. This is a tool where you're hitting it with a brush in order to strip off the outer layer of lime or binder from the mortar joint so that it maintains an appearance of a traditional weathered mortar joint that's had time to actually be exposed to the elements. This will also open up the mortar joint, so any improper compaction or working will basically be stripped away, and you'll have that proper permeability of the mortar joint right off the bat. And it will also allow you to blend it into the surrounding mortar that has not been replaced or repaired. For cleaning, there are basically two options you have if you need to do any cleaning. If your mortar is dry enough and you do a proper churn brushing technique at the end, there should be a minimal amount of cleaning because anything coming off is going to be in much of a drier, powdery texture than a more smearing texture that will require more cleaning. But you either clean immediately after the mortar joint is finished being tooled by just dry scrubbing it with a stiff bristle brush, or after the initial setting with pure water and some stiff bristle brush. You want to avoid using any kind of chemical cleaning or chemical detergents as much as you can, especially early on in the curing process, because it will significantly damage the mortar that's been installed. And so you need to make sure that whatever cleaning you're doing is doing the minimal damage to what's on there now. If you do need to use a chemical cleaner for some reason, you need to wait at least 28 days, preferably longer, for the mortar within the joint to firm up enough and have enough of a curing to be resistant to whatever cleaning is going to be happening there. Finally, you need to go through the proper curing and dampening procedures. This is another area where there is a lot of failures, especially in first-time contractors. The first 3 days after the installation of a historic mortar are very essential. For non-hydraulic mortars, which is basically pure lime mortars, you need to go through wetting and drying cycles where you're going to wet down the wall, you're going to let it dry out slightly, and then wet it down again, typically 9 cycles for the first 3 days, so about 3 times a day. What that does is kickstarts the curing mechanism of lime, which is carbonation. It's absorbing carbon dioxide out of the air, and that watering and that wetting down is basically pulling carbon dioxide into the wall and then releasing it as that water soaks in and evaporates out. The other type of mechanism that these historic mortars go through is hydration. So basically chemically reacting with water in order to harden. And that needs to happen ideally over the first 3 days, so same time period. But instead of allowing the mortar to wet and then dry out slightly, you want to maintain a slight damp condition the entire time so that hydraulic set continues uninterrupted. If it does dry out before the 72 hours are up, it can completely stall the chemical reaction of the hydration, and it's difficult or impossible to get it to restart. So you may not be able to achieve a high level of strength if it dries out too quickly. So this is a case study we're going to go over of a church in Poland. This is actually from a wedding Mario attended a number of years ago. But if you look up, you notice that there's something going on with the gable of the interior of this church. And is there something wrong with the roof? Is there something wrong with inside? Just why is there so much water coming through on the inside of this church? So if you go around and you look at the outside, you talk to them and say, oh, we just had the roof repaired. We just had a mason up there doing work. And you can see that, yeah, the top couple of feet of this church had repointing done on the masonry. But if you look at the areas that were repaired, quote unquote repaired, and the areas below it, what do you notice? You notice that the mortar joints up top are completely dry, and the mortar joints down below are completely damp and wet. The mortar joints down below are acting as the wick of the wall and are letting the mortar or the water within the structure evaporate out. But the mortar on the upper edges is completely trapping whatever moisture is trying to escape from the wall and pushing it back inside. So this type of mortar has completely reversed the moisture gradient of the wall and is now pushing it inside where it's getting dark, it's getting mold or mildewy, it's causing all kinds of issues. And there's not really a good way to fix this without cutting out all these new mortar joints to allow the moisture to escape back the way it came. I'll double check if there are any questions coming through. Okay, so yeah, we'll save all questions for the end just because we are running a little late. I'll try and speed up a little more through the next two sections. These ones are shorter. But basically, these next two sections are going to cover specification development and on-site audits and just inspections you need to do. So when you're writing historic or specifications for historic projects, there are a number of sections that are going to be different from a standard specification. You need to have modifications to your references, your submittals, your substitutions, your quality assurance, your delivery storage, your environmental requirements, your products, and your execution. For references, you need to include definitely a reference to National Park Service Preservation Brief number 2. There are also specific ASTM standards that deal with historic masonry. These numbers, you don't need to look them up now. You can pull them off of the slide deck at a later date, but they basically reference what will help you get the right testing and results in. For your submittals, you need to make sure that all the products have product data sheet and SDS submittals with them, that you're calling out for a matched material or matched masonry to match the existing based on material testing. And you need to make sure that you either have a requirement for experience, masons required 5 successful projects within the last 5 years of an equivalent level, and or a training and certification program. Make sure that the masons are engaging with a certified training professional to make sure that they are capable of doing the work. You want to make sure that you don't allow substitutions. You need to make sure that all the original materials match, or all the failure materials match the original materials in terms of sand, ingredient proportions, binders. You want like to replace like. If possible, you want to call for benchmark mockups for quality assurance. This is where you call in a preservation consultant to assist with the initial spec development and scope of work. They would install a mockup on the building to actually go through approvals for color, texture, performance, and that mockup will stay on the wall during bidding and also ideally during the execution of the work. Because if that mockup is there, then the contractors can be required to execute an on-site mockup as part of the pre-bid qualification process so that the building owner or the architect can look at the approved sample and the contractor sample side by side to determine if they're actually capable of executing the work to the level that you have already approved and determined is possible. It is essential to make sure that your materials are delivered in the proper containers to protect them from the elements and that they are not exposed to extreme heat and freezing temperatures. Some of these materials do have temperature requirements and can have issues or failures if they're not stored properly. For environmental requirements, you want to be ideally above 40 and below 90 degrees for your installations. If you are not, then you do need to have a specific call out for site protections. Below 40 degrees and you run into issues with freezing and slowed down chemical reaction. Above 90 degrees, you run into issues with flash drying or moisture evaporation issues due to exposure. For your repointing materials, you need to make sure that you have a material analysis performed and that your matching material matches that criteria from the analysis. Fat group blended is the best option where you have something that you have a quality control product code sample to reference and make sure that those materials that are coming in are being matched in the factory and in the field. You need to be very specific with your list of allowable tools and techniques. So tool requirements, what is allowed, what is not allowed, and be very specific with how your removal depths and profile requirements are called out and that you've got the proper cleaning of the masonry walls after the removal is completed. Installation, same things we talked about before. You've got the proper site protection. You call out the pre-wetting. You have a specific joint filling and lift schedule. You have a specific call out of your finishing requirements. And then the cleaning and the curing, once again with cleaning, what you're allowed to, and more importantly, what you're not allowed to do for cleaning. For quality control, you want to ensure that they retain not just the benchmark mockup of the initial consultant, but also the benchmark mockup of the winning contractor to make sure that they are maintaining that quality control that they already proved that they're capable of, and they don't just go and cut it out so you have no reference as soon as the job starts. So this is St. Andrew's Military Academy. This was a project that we worked on that had a specification written for it that called out some new mortar to repair their parapets. As soon as they started work, they started having all these water issues. They initially thought that it was damage to the roof or to the parapets, but as you look closer into it, you can see that in the areas where you've got the damp stones, the mortar joints are dry, and in the areas you have the dry stones, the mortar joints are damp. So it's not actually water coming through from behind the parapet walls. It's water absorbing into the face of the stones, but coming back out through the stones or retaining in the stones instead of working out. So this was a specific example of an improper mortar specification. We were able to go in, cut out the areas of work that had been redone, replace them with a suitable permeable mortar, and those areas that were darkening, dampening, they basically lighten back up and resolve themselves just from addressing the water accumulation that was being encapsulated. The last section, which I can get through pretty quick, execute evaluation. So this is a very key step. You need to make sure that as the project is going on, that the contractor is doing the work according to your specification. So the things to look up for are making sure that your mock-up was executed correctly, making sure that they're removing the old mortar correctly, installing the new mortar correctly, curing correctly, and then your final inspection to make sure that it has met the original mock-up approvals. Your mock-up should look for specific approvals for the mortar joint profile, its color, the aggregate appearance, the soundness of the mortar in the mock-up, as well as making sure there's no cracking. You also need to make sure that your masonry units have proper edge condition, there's no mortar residue, and the mortar is bonded correctly. And once again, you want them to retain these mortar mock-ups until at least the very end of the project, so you can come back for reference. For the removal phase, you need to make sure that they're removing to the right depth and profile. Any remaining mortar has soundness and is confirmed to not need removal, and that you have proper dust removal, as any residual dust that's not cleaned out can cause a mortar bonding issue. Masonry units, make sure that the edges are intact, make sure that the masonry unit moisture levels are appropriate for the installation. For site protections, you need to make sure that you have the proper protections from excessive temperature or exposure controls. Bright sunny walls are going to need better protection from flash drying than shaded north-facing walls. If you're at the beginning or end of the season and you've got freezing temperatures coming in, you can do heating protections, different types of sun and wetting protections, but those need to be accounted for and need to be confirmed that they're being followed, because we have seen a number of projects where installation was done when it was too hot and the mortar flash dried and failed. Installation was done right before it started freezing, a week or two after the work was done, and all of the mortar blew out from freeze thaw within one season. Make sure that they're actually using the materials that are called out. And as that sort of weird edge case, make sure that the water is not brackish, funky, non-potable water. Make sure that they're actually using the tools that you called out for: water sprayers, trowels, hawks, pointers, not using inappropriate tools, grout guns, grout bags, anything that's going to damage the wall. Make sure they're following your actual installation procedures as called out for in the specification. You're doing proper lift installations, you're overfilling and then retooling at the proper hardness when finishing, tooling to the proper profile and using churn brushes or other opening methods, and only cleaning in those non-destructive methods during the initial work. You definitely need to make sure that they're following the cure conditions. This, once again, is one of the biggest areas of failures on these projects that we see is improper curing. They install it on a Friday afternoon, go home for the weekend, don't touch it, come back, and the mortar has not cured correctly on Monday, and they complain that there's something wrong with the project. Early freeze thaw protection is much more needed for these types of older, softer mortars. So lime putties, hydraulic limes, typos, make sure that they're not running into freezing weather, and if they are, it needs to be protected. Final inspection, you need to make sure that the mortar on the wall matches that pre-approved color, aggregate profile, joint profile, and that there's no cracking. And you need to make sure that the masonry units do maintain that good mortar bond and there's no mortar residue on them. This last case study we're going to show was a mortar that we actually matched for the City Hall in Lake Forest, Illinois, just down the road from us in Chicago. And Mason bought the mortar from us, came, installed it. We got a call from City Hall, and they said, "There's something wrong with your mortar." We came and we looked at it and we said, "There's nothing wrong with the mortar. They just installed it. They didn't cure it correctly." And they were very rough with actually smearing it across the wall. We had another mason come in, take the exact same mortar from us, cut out the work that had been done, install that exact same mortar mix, and it basically was a perfectly blended mix. So this was something where this was the mason just not following the proper procedures. They read the spec, they bid on it and ignored it, and no one was there to see them doing the improper work. So this takes us to the end. Sorry for running a little bit late. At this point, I can go ahead and see if there are any more questions coming through. So let's see. First off, we've got, is there a general rule of thumb for pre-wetting existing historic masonry mortars before installing new mortars? So the general rule of thumb is you always want to reach that idea of surface saturated dry. So where the wall basically won't absorb any more water, it will just start dripping off or sheeting off. That is getting you to the closest element you want, or point you want to. That being said, you can run into issues if there's excessive saturation within the wall before you start. So if you want to have a little more of a technical measurement tool, if you take a moisture meter and you start measuring the moisture of the brick as well as the mortar on the surface of the wall, and in some cases drilling portholes into the mortar joint to measure deeper in the wall, if you're seeing moisture levels in excess of 25, 30%, you've got too much water in your wall and you're going to run a risk of oversaturation there. Ideally, you want to cut out your mortar joints, let them dry for an extended period of time, potentially months, before you go back and do the work. Ideal wall mortar or moisture conditions are probably 15 to 20%. 20 to 25% is usually acceptable. North of 25% on a case-by-case basis with close monitoring. But beyond that, you just need to make sure that when you wet down the wall, you're not having very rapid absorption anymore. You've got enough saturation in that surface of the mortar that it's, or the masonry, that it's not going to pull the water out of the mortar, because that's really what the whole pre-wetting is to do. It's to stop the walls from immediately sucking all of the water out of the mortar as it goes in. Is any amount of joint shrinking acceptable for the integrity of the joint? If there's a hairline crack between the joint and the stone surrounding the joint, is that a failure of the joint and should it be redone? If there's a separation between the mortar and the masonry unit, then that typically is going to be a failure of the installation and would likely need to be redone. For certain types of mortars, specifically lime mortars and to a degree hydraulic lime mortars, if there are small shrinkage cracks that are not regular, but just sort of here and there, you can actually go back and retool a mortar joint a day, 2 days, sometimes 3 days after, depending on how the curing conditions are happening. And retooling of small hairline shrinkage cracks into lime mortars is perfectly acceptable. That will reform it. If you are seeing shrinkage cracking, it's likely from a couple of sources. The sand being too fine, the mortar being too wet, or the wall being too dry. Beyond that, if they allow the mortar to evaporate too quickly because it's too hot, there's too much sun exposure, that's another source where those fine cracks can form. But generally, if you are seeing regular, consistent shrinkage cracks throughout the wall, there's probably an underlying issue with what's going on. A hairline crack here or there that can be retooled, that's usually all right. The next question, mortar removal prior to repointing. How do you determine the appropriate depth of removal? The standard practice is to go 2.5 times the width of the mortar joint. In more conservative cases, you can go about 2 times the width of the mortar joint. You don't want to go any shallower than that. You also want to go as deep until you reach sound material. So in a case where there's deeper deterioration of the mortar, dig as deep until you get to a point where you are hitting sound material. If the mortar deterioration is so deep that it basically just goes and you're pushing through to the other side of the brick, then you can do something called back pointing, where you essentially take a looser kind of mix of the repair mortar and just sort of pack it in as deep as you can get, but don't push it in so it pushes all the way out the back. Let that set up enough that you can start doing a consistent pack up against that backing mortar in order to hold that main repair mortar in place, and then just bring it out using lifts in order to make sure that you've got a stable joint to pack into. But 2 to 2.5 times is typical. So standard 3/8 inch joint, go at least 3/4 of an inch, probably closer to an inch in depth, or until you reach sound material. The last question I see here, any advice for how to regulate site mixed mortars besides watching it be mixed? If you are really needing site mixed mortars, the easiest method, which is something we actually see a bit on certain types of plasterwork, just required that they used prepackaged ingredients. So this is only something I would say is appropriate for something that's going to be covered up. So bedding mortar where you have a matched pointing mix, base coat mortars or plasters where there's going to be something coloring on it, because you're never going to get a good consistent appearance out of a site mixed mortar, especially if you're matching to something that's already there. But if you do need to do some site mixing of mortars, basically if they establish a mixed design based on prepackaged quantities. So a full bag of lime, a full bag of cement, a full bag of sand, figure out a mix ratio based on those pre-measured packages. That will be able to create a pretty consistent performing mix. It still might not be a very consistent appearance mix. Are there any other final questions to hop on? I do apologize for us running a little late, but I hope you all are grateful to get a bit out of that.
No, that's entirely my fault for running overtime, catching up with you guys beforehand.
Yep.
I don't see any more questions, and wow, Ty, once again, fantastic presentation. Thank you so much.
Yeah, and once again, thank you all for joining us today. If you do have any questions just on general topics or on project-specific topics, feel free to reach out to us via email or phone. I'll send over the slide deck to pass around. And once again, everyone who wants to get credits for this, just be sure you submit your AIA number and we'll be registering those later today.
Thanks, Ty. Thanks, Mario.
Thank you.
Okay, thank you all. Have a good day, and we'll hopefully see you again soon.
Yeah, definitely. See ya.
Okay. Thank you.